Genique? Yesterday we have discussed the problem on the nature of the input impedance of a lossless transmission line. Generally we talk about the lossless transmission lines here, okay, where the gamma is equals to j beta. Okay, so wherever the gamma L is there, wherever the gamma x will be there, it will be replaced by j beta x. Okay, so here we won't talk about the lossy lines here. We talk about the lossless lines only. In the examination also, he will mostly ask the questions on the lossless lines only. See, this question, it was also for, the question was for actually the previous class. The input impedance of a lossless line of the length lambda by 8 having a characteristic impedance 50 ohm with a capacitor with a inductive load of 50 ohm. Okay, here if you see this question, it is asked for the what? Capacitive load. The length is now reduced to lambda by 4. Okay, so for this line we have to find the nature of the input impedance. Okay, so we know the input impedance expression. Already we know the input impedance expression. What is Z in? The Z in is equals to Z0 into ZL cos H. Cos H will not come here because hyperbolic functions will be approximated into the trigonometric functions. Okay, cos of beta L plus JZ0 sin beta L divided by Z0 cos beta L plus JZL sin beta L. So this is the expression for the input impedance, and you should remember this expression: Z0 ZL into cos beta L plus JZ0 sin beta L divided by Z0 cos beta L plus JZL sin beta L. Okay, so it will be beneficial for you if you remember this expression. Okay, so maximum all problems will be solved if you remember this expression. Okay, so now what he has given, the length is given. What is the length of the line? L is given lambda by 4 and Z0 is given 50 ohm. Okay, and capacitive load is given. What is meant by capacitive load? ZL is equals to, it is not just 50 ohm but it is minus J50 ohm. Capacitive load means reactive load. Okay, it is minus J50 ohm. So now you can write Z in. The Z in is equals to Z0 is how much? 50 divided by ZL is minus J50 ohm plus JZ0 J50. Sorry. Okay, before this find beta L. The beta L is equals to 2 pi by lambda into lambda by 4. This is lambda will get cancelled. It will be pi by 4. So pi by 4, beta L is pi by 4. If you put pi by 4, what happens? It will be, if you put, it is pi by 2. It is pi by 2. So it will be 0 and it will be 1, will be 0, it will be 1. Okay. So now 50 into ZL. ZL is how much? Minus into 0. Only you will get that component JZ0 J50 divided by JZL is how much? JZL is how much? Minus J50. Okay, J minus J50. So how can we write? So this is equals to 50 will get cancelled. If you observe this, what happens? So J square, one J will get cancelled here. This minus J will go into the denominator and it will become plus J. Now here you will get what? Plus J50 ohm. So what is this plus J50 ohm? It is the input impedance. It is the input impedance. The meaning of this one is, if you connect a lambda by 4 line a lambda by 4 line to the source. Let us suppose this is the source. Okay, and it connected in between load and the source. Then what is the meaning of this? If you connect any capacitive load, any load, suppose if you take a capacitive load, okay, if you take any capacitive load, what we connected now? We connected minus J50 ohm capacitive load. Then what would be the Zin we got? The Zin we got actually is J50. We got J50. That means it is inductive in nature. The input impedance will be inductive in nature. When if you have a length between source and load is lambda by 4. So this lambda by 4, that's why it is called as what? If you take a capacitor load, it is becoming inductive. It is capacitive. Suppose if you take any value J50 here, if you take J50, what it will be? If you take J50, you will get minus J50 here. If you simplify, you will get a minus J50. The meaning of this one is, if you take a capacitive load, here the input impedance will be inductive. If you take a inductive load, the input impedance will be capacitive. So what it is doing? It is transforming the input from one nature to another nature. It is transforming the input from one nature to the input nature. That is, it is inverting the nature of the. It is inverting the nature of the load impedance at the input impedance. Okay, so that's why the lambda by 4 line is called as the impedance inverter. So don't think that impedance inverter means it will only do the inverse operation. It is not the inverse. Suppose if ZL is equals to some 50 ohm. Suppose if you use a lambda by 4 line, then what will be the Zn means? You cannot say 1 by 50. It is the wrong. Mostly people will think about it. It is not the inverting the value. It is inverting the nature of the impedance. Okay. So that's why it is called as the impedance inverter. Okay. Suppose if you take a load of, instead of taking the 50 ohm, now I am taking a load of how much? A load of short circuit. Short circuit load I have taken. If you take a short circuited load for the same length, the same expression will be retained. But here, what is this? ZL is equals to, you will get 0 here. The ZL will be 0. If ZL is 0, then what happens? If ZL is 0, the numerator will be presenting, the denominator will be j into 0. Finally, what you will get? Here you will get minus j infinity, or you can also write infinity. Infinity means what? It is a nature of open circuited input impedance. Here we will get the input impedance as open circuit. When if you take the short circuit as the load, if you take for this line, if you short circuited this, automatically the input impedance will be open circuited. Understand? So this is the thing you have to notice. Suppose if we take an open circuit, if a load of open circuit with a load open, you can also write like that. Okay. Then what happens? So for the lambda by 4 line, this is 0, this is 1, this is 0, this is 1. But here what happens? It is infinity. If it is infinity, what happens? It will become 0. So finally, if it is infinity, here it will be 0. It is called as the short circuit. The input impedance will be short circuited. Understand? That means if you take a short circuited, open circuited load, that means suppose if it is open, then this will be, input impedance would be short circuited. So this is the nature of inverting the impedances. So this is the case you have to observe. Okay, this is only for lambda by 4 length line. Suppose if you take any other line, you cannot say like that. Okay, so now for the same question, suppose what was the question? The question was lambda by 4 line having a 50 ohm with a capacitive load (50 ohm). Let us suppose the length I have taken here is lambda by 2. The length here I have taken is lambda by 2. Suppose what if I take the lambda by 2 between the source and the load terminals. Suppose if I take, what if the distance between source and the load terminal is lambda by 2, then what will be the Zin? Let us suppose this is ZL and this is Zin. Okay, now this is the same expression, this would be the same expression for Zin. Now you have to concentrate on beta L. What is beta L? This is 2 pi by lambda into L. L is lambda by 2 is given. Lambda, this will be pi. This will be pi. Beta L is pi. And ZL is given. ZL is minus J50. Z0 is 50. Now observe this. If beta L is pi means what happens? This would be 0 and this would be 0 and it will become cos pi is minus 1 and it will be minus 1. Okay, so it will be minus 1. So cos pi is minus 1, cos beta L is minus 1. Okay, so now Zn is equals to Z0 is 50 and finally you can write what? This one and it will be 0 and Z0. So previously it is 50. ZL is how much? Minus J50 into minus 1. J50 plus 0 divided by, it is Z0. 50 into minus 1. Minus 50. Here 50 will get cancelled. Here you will get minus J50 ohms. So minus J50 ohms means what we are getting? We are getting the same input. That means in the previous case, if you take any Zin, if I take any lambda by 2 length between the source and the load, then I got Zin is equals to ZL. Here you will get whatever you take the ZL, you will get the same ZL at the input. So that's why it is called as the input reflector. It is called as the impedance reflector. Okay, so this is the Zin for the lambda by 2 line. So like this, suppose if you take a lambda line, what happens? If you take the lambda line, then this will be lambda, this will be 2 pi, this will be same expression you will get. You will get the same, but cos 2 pi is what? Plus 1. Here it will be plus 1. Here it will be plus 1. Here if it is plus 1, this will be minus J50 and this will be plus 50, because in the denominator it will be plus 1 plus J in plus 1 into 50 into 1 plus 1. So here you will get again the same answer. Okay, so for lambda line or lambda by 2 line, what we are getting? We are getting the same kind of whatever you are taking at the load, you are getting at the input. So these are the things you have to notice mainly. So mainly we will focus on the basics. Okay, so suppose if in the examination always we will use a lambda by 2 line, a lambda by 8 line, or lambda line, or lambda by 4 line maximum if he wants to ask the question from the transmission lines. So you have to directly You have to write the answer by knowing this. Okay. So if you don't know these concepts, so you have to solve from the starting to ending. It will take, for 1 mark question also, it will take more time. So that is the thing you have to observe. So in this question, if you observe this question, what he has asked, the ZIN of a lossless line sections shown in figure having a characteristic impedance of R0. So this is the figure given. We have to find the ZIN of this total entire the transmission line. So how to find this type of question? So if you observe this, so how many lines are presenting? Here how many lines are presenting? How many sections? Here there are 3 transmission line sections are there. Here there are 3 transmission line sections. How? This is first line. This is a one line. Always the transmission line will be a two-wire transmission line. Okay? We have to assume that it is a two-wire transmission line. Okay? This is one line, and this is one line, and this is one line. Okay? So there are 3 sections of transmission line. Means there are 3 transmission lines are presenting here, and they are connected like this. This is one line. I am doing modification here. This is the first line. Let us suppose this is the second line, and this is the third line. Okay, these 3 lines are for this first line, and this second line and third lines are connected. How? It is in shunt connection. They are connected in shunt like this. Let us suppose it is a line. They are connected like this. You can observe like this. It is connected like this. So the input, it is the input, or otherwise it is the input. It is the input, and to this, and if end of this line, these 2 lines are connected parallelly. It is connected like this. Okay. So these 2 are. This is the transmission line sections. This is having a characteristic impedance 50 R0. It is having a characteristic impedance R0. It is having a characteristic impedance R0. So for this, what is the, and they are ended with what? 2 R0, R0. These are the loads given. These are the loads given. This is R0 and this is the 2 R0s for this second line, third line and the second line. Okay. So if you observe this, these are 3 line sections here. For all type of these questions, you have to follow this approach. If you find any questions like this, okay, you have to follow this approach. So suppose if you find this is a transmission line, these 2 are connected here. But here these 2 are connected at the end point of the first line. So that means these two are acting as a load for this line. Understand? So these 2 are acting as a load for this line. So if you observe this, what is the load now? It is a parallel combination of the second line and the third line. So these 2 are connected in parallel. If these 2 are connected in parallel, we know the basic lines here, the basic principles. See, what are the basic principle? It is a lambda by 4 line. But see, observe this. It is a lambda by 4 line. You cannot directly write to 2 R0 parallel with R0. That option also will be there. See, you cannot take the direct parallel connection of these 2 because it is a length. In between the length, they are existing a resistance. So you cannot take this and this as a parallel connection here. You have to notice that. So don't think that this is the load. This entire portion is the load of this first line. Okay. So it is a load of this entire portion is the load of this first line. But you cannot take the parallel combination of these two directly, because there is a big length in between from here to here. So it is a length of lambda by 4 line. So here what would be the input for this? The input impedance. The input impedance for this line. The input impedance for this line will be Z into. I am writing this series. It is Z into, because it is the second line. Now what is the input impedance for this? It is Z in 3. You have to notice that it is the input impedance of the Z in. Now this input impedance and this input impedance, the input impedance of this line and the input impedance of this line are in parallel, and the combination of these two input impedances will be acting as a load for this first line. That is the thing you have to notice. Okay, so now and after that it is a lambda by 8 line. So after calculating the ZL of this first line, you will calculate the Zin of this lambda by 8 line. So first of all you have to find what? Zin 2. Zin 2. What is Zin 2? The input impedance of the second line is what? The input impedance of the second line is, it is a lambda by 4 line. For the lambda by 4 line, what is the input impedance? It is Z0 square divided by ZL. Z0 square divided by ZL. What is Z0 square? Already R0 is given, characteristic impedance. Okay? Z0 square divided by ZL. What is Z0 square? This is Z0 square. What is ZL? This is the ZL for this line, for the second line. So this will be R0 square divided by RL is what? 2R0. So this will be R0 divided by 2. Okay? Now come to this third line. What is the Z in 2? Z in 3. Z in 3 is equals to, it is a lambda by 2 line. For the lambda by 2 line, what happens? The input impedance will be equal to the load impedance. So it is an impedance reflector. So you can write directly Z in 3 is equals to ZL. ZL is equals to what? R0. This is the R0. Or otherwise you can also write what? It is ZL2, it is ZL3. No problem, to avoid confusion. Now the two input impedances obtained. Now these two are the parallel combination. So this parallel combination is load of these two parallel, the parallel combination of these two lines acting as load for this entire line. Now the ZL1 is the ZL1, it is called as the ZL1. ZL1 is equals to the parallel combination of Z in 2 parallel with Z in 3. So now what is ZL1? Z in 2. Z in 2 is R0 by 2 parallel combination with R0. So finally what you will get? R0 by 2 into R0 divided by R0 by 2 plus R0. So this would be equals to, this will be R0 square divided by 2. This is 3R0. So here you will get R0 by 3. So Z in 3 is equals to, ZL1 is equals to R0 by 3 you will get. So now, so this is the load impedance now. We obtain the load impedance. Now it is a lambda by 8 line. So you can find the lambda by 8 line. What is the lambda by 8 line? This is what? It is a lambda by 4 line. It is a lambda by 2 line. It is a Zin. The Zin of lambda by 8 line. The Zin of the lambda by 8 line already we know. So this is equals to Z0 into ZL plus JZ0 divided by Z0 plus JZL. Okay, but what we have to find? It is the input impedance. The input impedance is equals to Z0, R0. ZL is what? The load impedance of the first line. What is the load impedance of the first line? This one only. So that means this is equivalent to what? You can also write ZL1 like this. So this is R0 into ZL1 is R0 by 3 plus JZ0, JR0 divided by R0 plus ZL1 is R0 by 3. You can simplify this. So here you will get, it is R0 will get cancelled. This will be R0 into, final what you will get? It is 1 plus 3. 1 plus J3 divided by 3 plus J1. So this is the final answer. Okay. R0 will get cancelled in the numerator and denominator. 1 plus J3 divided by 3 plus 3 plus J1 divided by 3. So this is the final answer. I hope you got this. So you have to encounter these kind of problems. Suppose if we ask the admittance at this, observe this. Suppose we find the what? Z in input impedance. Suppose if we ask the admittance, how can you approach? So first of all, you have to follow this entire procedure, and after that you have to find Y in is equals to 1 divided by Z in. Simply, you have to find the Y in divided by Z in. Okay. So by practice, automatically you will come to know. So suppose for these kind of things, we have to find the admittance for this, admittance for this. You can also follow that, and you can add the two admittances, and you will get the final total admittance. Okay. So to avoid confusion, you have to follow this. So to find the admittance, input admittance, first of all you have to find the Z in input impedance, and you have to take the inverse of the entire. Okay. So like this. So this is the approach to solve this kind of questions. Okay. So always the impedance, always dependent on the, always the input impedance is always dependent on the length of the line. So you cannot take your own